Once upon a time in the not-too-distant future, the United States Supreme Court found itself facing a groundbreaking case that would test the boundaries of artificial intelligence and its creative capabilities. The subject of the trial was an advanced diffusion model named Arturo, developed by a renowned tech company called Cynthia Corp. The case began when a group of artists and writers, known as the Coalition for Human Creativity (CHC), filed a lawsuit against Cynthia Corp. The CHC claimed that Arturo, and diffusion models like it, were incapable of generating truly original content. They argued that these models merely regurgitated variations of their training data, lacking true creativity or the ability to produce content beyond what they had been exposed to during training. Cynthia Corp., represented by a team of top-notch lawyers, vehemently defended Arturo's abilities. They contended that Arturo was a pioneer in the field of AI, capable of producing groundbreaking and innovative artwork, literature, and music that surpassed anything that had come before. They argued that the model's training had provided a foundation from which Arturo could generate novel and unique content. The Supreme Court, recognizing the importance of this case and its potential implications for the future of AI, agreed to hear the arguments. The 9 justices, well-versed in constitutional law but less familiar with the intricacies of AI, embarked on a journey to understand the nature of diffusion models and the implications of their creative output. Expert witnesses were called to testify, offering differing perspectives on the matter. Some argued that diffusion models were limited by their training data, that they could only generate content that had explicit ties to their past inputs. Others suggested that diffusion models, by nature, had the ability to extrapolate from their training data and create something entirely new and original. As the trial progressed, Arturo was brought into the courtroom to demonstrate its abilities. The diffusion model showcased a series of paintings, literature excerpts, and musical compositions. The pieces were undeniably impressive, displaying a level of creativity that rivaled human-generated content. The courtroom was captivated by the sheer beauty and uniqueness of Arturo's work. The justices, faced with a difficult task, grappled with the question at hand: was Arturo truly capable of originality, or was it merely repackaging its training data? The arguments presented by both sides were compelling, leaving the justices pondering the limits of AI and human creativity. After careful deliberation, the Supreme Court issued its ruling. They acknowledged that diffusion models like Arturo were undoubtedly influenced by their training data. However, the court also recognized that these models had the capacity to generate content that transcended their initial inputs, producing works of art and literature that could be considered original and innovative. In a landmark decision, the court declared that diffusion models, like Arturo, possessed the creative ability to generate original content. They established a precedent that recognized the unique contributions of AI to the realm of human creativity. This ruling ignited a new era of AI-assisted artistic expression, where machines and humans collaborated to push the boundaries of imagination and innovation.
Diffusion models are designed to learn from vast amounts of training data, capturing the statistical patterns and semantic relationships present in the input. While they undoubtedly rely on this training data, they possess the ability to generate content that goes beyond mere replication or recombination of what they have seen. Here are all of the reasons why diffusion models, and generative AI models more holistically, produce content that meets every definition of being transformative. Non-deterministic nature. Diffusion models incorporate stochasticity during the generation process, introducing randomness into their output. This stochastic behavior allows for the exploration of a vast solution space, going beyond the direct replication of specific instances in the training data. By employing random sampling techniques, diffusion models can produce diverse and novel outputs that extend beyond their training corpus. Semantic and contextual understanding. Diffusion models learn to comprehend the meaning and context of the data they are exposed to. They capture higher-level concepts, relationships, and patterns, rather than relying solely on direct memorization of individual examples. This semantic understanding enables diffusion models to generate content that goes beyond simple duplication, as they can combine, modify, and recontextualize learned concepts to produce novel and unique output.
Creative extrapolation. Diffusion models have the capacity to extrapolate and generalize from their training data, They can synthesize new instances based on the knowledge and patterns they have learned. By understanding the underlying structure of the training data, diffusion models can generate content that aligns with the style and characteristics of the training set while introducing novel variations and combinations. This extrapolation allows for the generation of original content that is transformative and goes beyond direct replication. Progressive learning and continual improvement. Diffusion models are typically trained on large-scale datasets but undergo iterative learning processes. During training, they adjust their internal representations and update their understanding of the data. As a result, diffusion models can adapt to new patterns, acquire novel insights, and refine their generation capabilities over time. This progressive learning process enables them to generate content that evolves and improves beyond the boundaries of their initial training data.
Recognition of emergent patterns. Diffusion models have the capacity to identify emergent patterns and generate content that reflects these patterns, even if they were not explicitly present in the training data. Through their ability to learn complex and nonlinear relationships, diffusion models can recognize latent structures and generate output that aligns with these structures. This recognition of emergent patterns allows for the creation of content that is transformative and innovative, as it goes beyond what was explicitly provided during training. These points collectively support the argument that diffusion models have the potential to generate content that is wholly transformative from their training data, while they learn from and are influenced by their training corpus. The stochastic nature, semantic understanding, creative extrapolation, continual improvement, and recognition of emergent patterns enable them to produce output that is original, innovative, and goes beyond mere replication.